Well, good morning everybody. So let me start by sharing. Right, so I want to move that to that side so I can see any comments that come in. That's what I want to see, so I can see comments if they come in, and I want to move this one to this side. You can't imagine what I was doing last time, can you? Let's have a new whiteboard. Right, so I'm hoping you've all got the handle on matrices by now, and I'm sorry about the strike. One thing I will be asking soon will be what we want to do about revision. So have a think about that, because we'll put up a poll. Sarah's got that ready, and what we get back, the top 4 are the ones that we'll concentrate on next week. So next week is all about revision. If we have a matrix, and I will just take any old matrix, let's do a 2 by 2. So let's say we've got 3, 5, 2, minus 4. For example, you can tell it's a matrix because it's got square brackets. So the matrix is A, let's say, and what I would like to do is to find the determinant of that, which is written like that. A determinant is always a number. Now before I calculate this determinant, I'll just put a plus here and a minus here, and you probably already know what I'm about to do, because I'm going to multiply the 3 times minus 4, which is going to give me 3 times minus 4, and then there's a minus here, isn't there? So I'm going to put that, let's stick that in red just to emphasize it, and then I'm going to do 5 times 2, which is 5 times 2. Okay, so 3 times minus 4 is minus 12, 5 times 2 is 10, but there's the minus there, so that's going to be minus 10. So the result of that is going to be minus 22. Now, I suspect most of you already know that, and you did this minus sign at the top here without really thinking about it. You just know that's how you do a 2 by 2 determinant. But what I'd like to do now is move that up a bit, and I'm going to do, let's call this one B. So I'm going to do a 3 by 3 determinant, which is 1, 5, 2, minus 6, 7, 3, 1, 9, 8. Okay, and I'm going to do the 3 by 3 determinant, which obviously is an extension of a 2 by 2 determinant. And as before, I'm going to put a plus and a minus and a plus. You don't have to write the pluses and the minuses, but this is just to emphasize to you what happens. Right, now let's have a blue pen here. So I'm going to take the first number here, the 1 in the position 1, 1. So this is B1, 1. So what I'm going to do is I'm going to put a 1 there, times, and I'll have a bracket. And then what I'm going to do is I'm going to remove that row and that column, which gives me, as you can see, a 2 by 2 matrix, doesn't it? And I'm going to expand the 2 by 2 matrix in exactly the same way as we've done before. And as before, we'll put a plus there and a minus there. So now if I put those values in, I'm going to get 7 times 8 minus 3 times 9. But before I do that, just let me remove some of these lines. So I'm going to get 1 times 7 times 8 minus 3 times 9. Okay, so that's the first one. Now I'm going to do the 5, only this time it's going to be minus 5, isn't it? Because we have the minus sign in front, times, and as before, I'm going to take out that row and that column, which now means I've got a 2 by 2, which is minus 6, 3, 1, 8. Okay, so I'll put those values in, so it's going to be minus 6 times 8 and minus 3 times 1, because of course I've got a plus here and a minus here in exactly the same way as the previous one. So let me just remove those. I'm going to get minus 5 times minus 6 times 8 minus 3 times 1. And then you can probably see where I'm going for the next one. Let's just take out the row and the column. So I'm going to take out that row and that column, leaving me with this matrix here. That's going to be a plus and that's going to be a minus. So I'll just remove those. So now I'm going to get plus 2 times brackets minus 6 times 9 minus 6 times 9 minus 7 times 1. Okay. Right, so Sunil is saying, does the 6 not become plus? No, when we did this middle row here, let me get the blue pen. So when we did the middle row there, the minus 5 was because of the minus there, but we took out that row and that column, and we would have had a plus here and a minus here. So the 6 remains minus 6, but the 3 becomes minus 3. So minus 6 is there and minus 3 is there. Is that okay? What about the 8? So it's minus 6 times 8. So minus 6 times 8. So that's correct. That doesn't change either. Right. So now what I need to do, let's move that up a bit, is to evaluate these. So that is going to equal, so mod B is equal to 1 times 7 eighths of 56 minus 3 nines of 27 minus 5 times 6 eighths of minus 48 minus 3 plus 6 nines of 54 minus 7, so that's 54, 61, so that's 2 times minus 61. That's not very consistent, is it? Let's do that again. So it's minus 54. That's not a very good 5. Minus 54 minus 7. Okay, so that's going to give me 56, 36, 29, so that's 29, and then I'm going to get 48, 51 times 5, which is 510, 250, 255, so that's minus 255. You can check this on a calculator if you'd be so kind. What did I say? That's 51, 510, 251, 251, not 255, 251, and then 54 and 7 is 61, so that's 122, so that's minus 122, so that's going to equal 373, 353, 344, 344. Okay, that's what I think it is. If anybody's got a calculator, can you just check that I've got those numbers right? So that is the determinant of a 3 by 3 matrix, and obviously we could go to a 4 by 4, 5 by 5, 6 by 6, and so on. So the determinant of a matrix is always follows the same rules, however big the matrix is, but it does have to be a square matrix. So it has to be a 2 by 2, 3 by 3, 4 by 4, or whatever. You couldn't do a 2 by 3 or something like that. Minus, thank you, Jack. Of course it's minus. Yeah. Okay. So that's how you do a 3 by 3 matrix. Okay, are we all right with that? Because we are going to need to do these. Clearly you don't have to do them in your head. It's just I prefer to do it that way, so you can see what's really going on. But everybody sees this plus minus plus business, because it's true for a 2 by 2, it's true for a 3 by 3, it's true for an n by n matrix. Okay. Right, so now what I'd like to do then, unless there are any questions on that, is I would like to have some simultaneous equations. So what about 5x, why do my 5s look so terrible today? 5x minus 4y minus z is equal to 19, and minus 3x plus 5y plus 5z is equal to 1, and we've got 5x plus y plus 3z is equal to 25. Okay, so we've now got 3 simultaneous equations with 3 unknowns. So 3 equations, 3 unknowns, which means these are soluble. Question is, how are we going to do it? Some of you probably know about multiplying this first equation by 5 and adding it to the second equation, and then multiplying the first equation by 3 and adding it to the third equation. That would give us 2 equations in 2 unknowns, and then we'd have to do something with the y's in the the two new equations, that would just give us x, and then we'd do all the back substitution and everything. But what I want to do today is look at a different way of solving it, which is a method invented originally by Gabriel Cramer, a French mathematician in the 18th century. We've got three equations and three unknowns, and what I would like to do is to find what value of x solves those three equations, what value of y, and what value of z. And basically what we've got here is, I'll give you a quick sketch. If I had a pen I would anyway. So x, y, z axes, that's x, that's y, and that's z, and these are three lines in three space. So there's one line that's going like that, there's another line that's going like that, and there is a third line, which can be blue, which is doing something like that. And these are all 3D lines, okay, and there's one point that they all intersect, okay, and that's the point we're trying to find. We're trying to find the x, y, and z coordinates of the point of intersection of these lines. These are three lines in three dimensions. So one way to solve them is by substitution, which you've probably done already before you came to university. You've done 2D substitution. I suspect some of you have done 3D substitution, but that's actually quite hard work. So what I'm trying to do here, no Samir, it jolly well isn't. So just focus and stay with me. So what I'm going to do now is, rather than do substitution, and by that I mean multiply this first equation by 5 and then add it to the second equation, that way the z's would disappear, then multiply the first equation by 3 and add it to the third equation, again the z's would disappear, and then instead of 3 equations in 3 unknowns, I'd have 2 equations in 2 unknowns, and then you'd have to do the whole thing again. And that is all a little bit about whether you can see the patterns or not. But what I want to do now is I want to use matrices to solve it, whatever the patterns. So I'm going to take out the coefficients of these equations. So I'm going to get 5, which is from there, minus 4, which is from there, and minus 1, which is from there. I'm going to get minus 3, 5, and 5. And I'm going to get 5, 1, 3, 5, 1, 3. Okay, so that is the matrix of coefficients. I need to multiply that by, if I can draw my lines properly, multiply that by x, y, and z, and set that equal to the matrix of constants, which is 19, 1, and 25. Okay, so what we've done here is we've taken 3 equations and we've rewritten them in matrix form. Yes, sorry Robin, I've just seen your comment. They may not have a common point, and if that's true, then these equations won't give us an answer. Okay, so I've taken 3 equations in 3 unknowns, and I've now rewritten them in matrix form. Is everybody all right with that? We've got 5 minus 4 minus 1, 5 minus 4 minus 1. Then in the second row we've got minus 3, 5, 5, minus 3, 5, 5. And then in the third row we've got 5, 1, 3, 5, 1, 3. Okay? And if we were to multiply this matrix, I'm going to call that A, by this matrix, I'm going to call that X, you'd put X, Y, and Z across the top there, and you'd multiply those two together, those two together, and those two together, which would give you exactly what we started with. Okay, so let's just remove all of that blue stuff. So now what we've got is A times X is equal to C. Okay, so that's my matrix of coefficients times the x, y, z, which is the point we're looking for, equal to these constant values. Right, so now what I'm going to do, now is I'm going to calculate the mod of A, and that is equal to, this is the determinant of the matrix of cofactors, so I'm going to get 5 times, so as before I'm going to take out that row and that column, so I've got 5, 3 minus 5, 1, so that's going to be brackets 15 minus 5. Then I've got the next part, which is I'm taking out that row and that column, so I've got minus 3, 3 and minus 5, 5. So that's going to give me, now remember the plus minuses, I'm going to get minus brackets minus 4, so that's the minus 4 from here, times, it's minus 3 times 3, so that's minus 9, and then I've got minus 5 times 5, which is minus 25. And then for the final one, that is actually minus 1, so I've got minus 1 times, and then it's going to be minus 3 times 1, which is minus 3, and minus 5 times 5, which is going to be minus 25. Okay, so for the last row here, well, let's start at the top here. We've got this number here, which is 5, which is that 5 there, so I take out that row and that column, so I've got 5 times 3 minus 5 times 1. 5 times 3 is 15, which is what we've got there. Minus 5 times 1 is the minus 5 that I've got there. Okay, so that's the first part, and now I'm going to go on to the minus 4. So let me just tidy this up a little bit. So now I'm going to do the minus 4, only remember the plus minus plus business that we get over here. Let's do that in red. Control Z. So I'll do red because we have a plus minus plus. Okay, so the minus there, the red one, is that minus there. Then I've got minus 4, which is the minus 4 in the bracket there. I'm going to take out that row and that column, which means I've now got minus 3 times 3, which is the minus 9 that I've got there. And I've got minus 5 times 5, which is the minus 25 that I've got there. And now I need to look at this value here, so let's tidy this up a bit. Right, so we'll put the plus minus plus back in, plus minus plus. So this time it's going to be plus minus 1, which is the minus 1 that I've got there. And then I'm going to multiply, this is the minus 1 I'm talking about, so I'm going to take out that row and that column. So I've now got this little 2 by 2 here, so it's minus 3 times 1, which is minus 3. And then it's going to be minus 5 times 5, which is 25, so I've got the minus 25 there. Okay, those are all the numbers, and that is the determinant of a 3 by 3 matrix. Good, thank you, Zishan. So now we're going to evaluate these. So A is equal to, says E with the right pen, 15 minus 5 is 10, 10 times 5 is 50, 25 minus 9 is minus 34, minus 34 times 4, double it is 68, double that is 120, 136, so that's minus 136. And then minus 25 minus 3 is minus 28, and then there's another minus there, so that's plus 28. So that's going to be 70 from 100, so that is going to equal minus 58. And somebody please check me with a calculator, but that's what I think it is. Okay, so let's just review where we're up to now then. We started with 3 by 3 equations, which are not trivial to solve. And what we've done is we've rewritten the equations in matrix form, which is what we've got here. Thank you, Jack. You're a valuable asset. So we've got we've rewritten it in matrix form here. Then what we've done is we've found the determinant of the matrix, which is minus 58. Okay, and I'm going to call that determinant D. Okay, and I will use this nomenclature across everything. So the determinant of the matrix of coefficients, this is the matrix of coefficients, the determinant of that I'm going to call D. Now this is where Cramer's method is about to start, because what I'm going to do now is I'm going to take, let's have the pen, I'm going to take these numbers and I'm going to replace these numbers with these ones. Okay, so I'm going to change the matrix, putting 19 here, 1 here and 25 here, and then I'm going to calculate the determinant again. So let's move that up. 19, 1 and 25. I'm going to have minus 4, minus 1 5 and 5, and I'm going to have 1 and 3. Okay, and this, I'm going to calculate the determinant of this, and because I've replaced the x column, I'm going to call this dx. So dx is equal to, and in exactly the same way as we've done before, I'm going to expand this matrix as a determinant. So I'm going to get 19, before I start, let's just put the plus minus plus up again, so plus minus plus, and then I'm going to take 19, which means that I'm going to remove this row and this column. So I've just got this little 2 by 2 in here, that's what I'm going to be working with. So let me just remove those 2 lines and go back to that. So I'm going to get 19 times 5 times 3 is 15 minus 5 times 1 is 5. Then I'm going to go on to this term here. So I've got a minus, but there's already a minus. So this time I'm going to put plus 4 outside, and it's 1 times 3 minus, and I've got 5 times 25, which is minus 125. And then I'm going to get onto the final term, which is minus 1. So I'm going to put minus brackets, and now it's 1 times 1, which is obviously 1, minus 5 times 25, which is minus 125. Okay, let's move that up a bit and evaluate that. So we're going to get, that's equal to 190. 125 minus 3, so that's minus 122 times 4 is 122, 244, 488, so that's minus 488, and this is minus 124, and there's a minus outside, so that's plus 124. Okay, 4, so that's minus 174. So what I can now say is that x is equal to dx over d, and that is equal to minus 174 divided by, now what was d? D was minus 58. 50 times 3 is 150, 8 times 3 is 24, 150 plus 124 is 174, so x is equal to 3. Okay, and that's found the x value. Now I'm not going to go through the matrices again because I think we've spent enough time on that. What I can tell you is that y is equal to dy over d, and if you want to do the calculations, and I invite you to do them, you will find that dy is equal to 116 divided by 58, and that is equal to 2 50s are 100, 2 8s are 16, so that's fairly straightforward, so that is equal to minus 2, and then we can say that z is equal to dz over d, which is equal to, again you can check this yourself, so it's minus 232 minus 232 divided by minus 58, and that is equal to 4. Okay, so that means in summary we've got a point x comma y comma z, and that is equal to 3 comma minus 2 comma 4. Now that might have seemed like some fairly hard work, but I think that's a much simpler way of doing this than it is looking for different things to substitute, looking for different substitutions on here. And just for the record, if you had to do calculations next year about things in 3D, whatever they are, it could be mechanical, it could be electronic, it could be chemical, all of those quite easily, what you can do is to put this technique into a spreadsheet, which means that all you've got to then define is your matrix of coefficients and the vector of constants. Okay, and then this will just work every time. So we've now got a systematic approach to solving 3 simultaneous equations in 3 variables. Okay, so that basically covers the material I want to deal with. Alexander, do you substitute the 9, 1 and 25 into, yeah, okay, so what I would do now as a sanity check, and this is answering your question, Alexander, is I would put my, what did I get? I got 3, 2 and 4. So let me just do it here. Let me change my pen color. So x was 3, y was -2 and z was 4. So it doesn't matter which of these equations I'll take. I'll take this one because it's the easiest numbers, isn't it? So I'm going to put those values into, I'm going to put x, y and z into that equation. So I've got here -3 times 3, so I'm going to get -9. I've got -2, so -2 times 5 is going to give me -10. Yeah, that's right, -2 times -5. And then z is 4, so 5 times 4 is +20. Okay, -9 minus 10 is -19, plus 20, and that equals 1. There's a 1, and there's a 1. Okay, so that's my sanity check. I've put my values for x, y, and z into one of the equations. If you wanted to be really careful, you could put them into all the equations, but I'm confident now that these are the correct answers. Okay, so just in summary then, let's just go over this quickly before I jump into breakout rooms. We've got 3 equations in 3 unknowns here. And what we did, first of all, is we created the matrix of coefficients. That's the word I wanted to say. So we create the matrix of coefficients, the matrix of the variables, and the matrix of constants here. First of all, we find D, which is the determinant of the array of coefficients. And then we substitute the constants into the x column, and that gives us dx. We find that determinant. Then we put the 19,125 into the second column here, and then we get dy. And then we put the 19,125 into the third column here, and that gives us dz. Okay, and then x is equal to dx over d, y is equal to dy over d, and z is equal to dz over d. Okay, it's that simple. And just so you know, on an exam you'll be asked to calculate d, dx, dy, dz, then find x, y, z, and then give me a sanity check. Okay, I think this is time for you to have a crack at it.